Our next speaker is Maia Weinstock, and she's the author and deputy editor director of the MIT News, which is a publication of the Massachusetts Institute of Technology. She's going to give an amazing talk. When I read through the slides, I was, blown away about Mildred Dresselhaus. And take it away.
Thank you so much, Ed. I really appreciate it. I just want to say thank you first to everyone for being here, to the NAE for hosting the symposium. I'm very excited to give this talk, but I'm also super excited to hear from everyone else and hear their experiences and their contributions to engineering. And so I'll go with that and go ahead and share my screen. Let's see. Okay. All right. So today I'm going to be talking about Mildred Dresselhaus, who many of you know was an very exciting engineer and physicist in solid state physics. This is going to be a 15-minute talk, so necessarily I'm going to have to leave out some things, but I recently wrote a book about her called Carbon Queen. And obviously, if you'd like to learn more, you can check that out later. Also, just a brief programming note, I am going to refer to Millie as Millie. Throughout her life, people called her that. Obviously, Professor Dresselhaus was highly esteemed, but just in general, anyone who knew her, her colleagues, family members, friends, and even frankly, just strangers that she just introduced herself to, she would say, please call me Millie. So I'm going to refer to her as Millie in this talk. Okay. All right. So as some of you will know, Millie Dresselhaus was a brilliant materials scientist and engineer who earned the nickname Queen of Carbon for her highly influential discoveries relating to the properties of carbon, although she certainly studied other materials as well, particularly semi-metals, throughout her nearly 60-year career. Millie was a longtime professor of electrical engineering at MIT, and she later earned an appointment in the Department of Physics as well. And while she was trained as a physicist, Millie was originally hired to teach the next generation of engineers the physics that they would need to know in order to develop the technologies of the mid and late 20th century and the earliest 20th century, early 21st century. Among her many achievements, Millie co-authored nearly 1,700 papers, 8 books, a handful of patents, and she also had 4 children. So many people have said in my discussions of my book that they get overwhelmed hearing about how much she was able to accomplish, and I have to agree. But all the more reason why it's important to tell her story. At left here, we see her in 2014 as President Barack Obama was presenting her with the Presidential Medal of Freedom, which along with the Congressional Gold Medals are the highest civilian honor you can receive in the United States. And Obama stated that day that Millie's influence is all around us in the cars we drive, the energy we generate, and the electronic devices that power our lives. So on the right, we see 7 carbon configurations or allotropes, including diamond, graphite, Buckminster fullerene or Buckyballs, and carbon nanotubes. And Millie worked for many decades to uncover some of carbon's fundamental properties, especially relating to the electronic structure of some of these forms. So I'm going to take things way back and just briefly go over her early life because it's really important to get a sense of where she came from to really understand and appreciate where she ended up toward the end of her career. Mildred Spivak was born in 1930 in Brooklyn, New York, but grew up primarily in the Bronx. She was a wide-eyed child who had to navigate the trials of living during the Great Depression. And she was the daughter of immigrants who, for a long while, sometimes had trouble putting food on the table. It was a really difficult existence for her and for her family. And she actually said this many times, that it was the hardest thing in life that she had to do was to overcome her childhood. Millie's elementary school and middle schools, and that left, you'll see her in her middle school picture. They lacked strong academics and structure to lead her into a career in, science or engineering. And keep in mind, this was a time when women were not expected to go into these areas. In fact, women were generally expected, she often said, to if you wanted to have a career, be either a nurse, a secretary, or a teacher. But Millie earned a scholarship to study violin at a music school in Manhattan. And the lessons she had there and the people that she met helped her understand that there were opportunities out of her impoverished background. And so she was able to figure out how to study for the tests that would get her into one of the magnet schools, which was the only one that was open to girls at the time. And so she aced the exam and she got into Hunter College High School in Manhattan, which is where she went. And going there really helped her see what might be possible. I also should just note that for a while, Millie actually worked as a child laborer, putting together zippers in a zipper factory. But at the end of by that time she became a high school student, she was earning enough money to become financially independent through some tutoring that she was doing. And this opportunity served her a little bit of a preview of her teaching skills later as a professor. And then you can see her high school yearbook quotation: any equation she can solve, every problem she can resolve. Mildred equals brains plus fun. In math and science, she's second to none. I think that was true throughout her life. I'm just going to show you briefly. These are two of Millie's great mentors in her education. On the left is Rosalind Yallow, who Millie met and instantly bonded with when she was an undergrad, and Yallow was her physics professor at Hunter College in New York. Yallow saw in Millie a bit of herself. She was whip smart and highly curious about the world. And Yallow all but insisted that Millie changed her plan of becoming a teacher to instead pursuing a career in research, which, of course, that's what she did. Yallow herself would end up winning a Nobel Prize in medicine, and the two remained close for many decades. On the right, many of you will recognize Enrico Fermi, another Nobel laureate who was also a significant mentor of Millie's. The two knew each other only for about a year. It was the last year of Fermi's life before he died. But Millie was a PhD student at the University of Chicago in their physics department. And Fermi would regularly invite her to cross the street and chat with him on the way to school, basically on the way to class. And from him, Millie learned the value of listening to and encouraging young people, the importance of a broad foundation of one's chosen field in science or engineering, and the ability to pivot and change direction if that ever becomes necessary. And that definitely happened in her world, and it happens to all of us, frankly. All right. Millie's longtime husband was Gene Dresselhaus, a theoretical solid-state physicist who also became one of her closest professional collaborators. The two were married in 1958 and had 4 children together. And on the right, you can see Millie here in the lab, along with her first child, Marianne, when Millie was a postdoc at Cornell, which was actually an NSF postdoc back in the late 50s. So Millie's PhD thesis was on superconducting materials, but when she and Gene got jobs at MIT's Lincoln Lab in 1960, Millie's supervisor at the time, Ben Lax, had told her to work on something else. Many at the time were starting to look into semiconducting materials, but turns out that Millie wasn't especially excited about semiconductors. So at Gene's suggestion, she took on what would later become her life's work, investigating carbon. At the time, carbon was considered to be too complicated to explore deeply, and her colleagues didn't think, frankly, that anything special would come of this research. So Millie took this as a challenge, and she was also happy to have carbon mostly to herself, which allowed her both the opportunity to have potentially an outsized influence on the development of this field, and also it let her focus a bit on raising of 4 kids. She had 4 kids in pretty quick succession. So if she had to take a sick day, it wasn't going to be a big deal because there just wasn't as much competition at the time. And this turned out to be a wise decision as she got in on the ground floor in terms of her eventual influence on carbon nanoscience and carbon generally. At right, we see a couple of carbon allotropes. One is diamond on the left, and on the right is graphite. Millie began her carbon studies looking at graphite with its layered structure, which has the in-plane bonds between the carbon atoms are extremely strong, but the between-plane bonds are relatively weak. So that makes it easy for you to leave some carbon on a paper anytime you are writing with a pencil. And Millie and Jean spent many years investigating so-called graphite intercalation compounds, which are sort of seen in this diagram below. Essentially, they are carbon layers mixed with other elements. And these investigations led to new and important insights into the electronic structure of graphite and carbon generally, which laid the groundwork for new science and engineering that have already led to some new materials, many new materials, and also laid the groundwork for technologies that are just now emerging, from things like flexible electronic screens to quantum computing, quantum computers. Okay, Millie joined the MIT faculty in 1967. First, she was a visiting professor in the Department of Electrical Engineering, and within a year was promoted to full professor with tenure, which is pretty amazing. She was the first woman on the electrical engineering faculty and just one of a few women on the MIT faculty at all. She became known not only for her research on carbon and other semi-metals, but for her pedagogical advances in terms of engineering education. Among other things, she helped to teach solid-state physics in a way that emphasized the various roles that engineering could play in applications then and looking ahead. She was also known as a professor who cared deeply for her students, and she made learning interactive and almost familial, similar to how she was treated by her mentor, Enrico Fermi. She also at this time began her work specifically advocating for women at MIT. Women had been accepted at MIT on and off since the late 1800s, which was actually much earlier than many colleges and universities even dared to accept women. But until the 1960s, it was still into the 1960s, it was still grappling with how women should be included as students, as well as faculty, administrators, etc. Millie helped to shape that attitude when she was first on the faculty. She worked to develop a women's forum, an important group that advocated on behalf of women across the institute. And she helped improve things like admissions criteria, which had previously made it extremely difficult for women to be accepted to MIT. And she developed a new course called What is Engineering, an introductory course that she co-taught with MIT aerospace engineer Sheila Widnall, that provided some basic background to women, students of color, and others who were new to MIT, but who hadn't benefited from, for example, a father who might have had, or a teacher who might have had, a shop in the background, or who might have previously introduced them to engineering principles, applications, career paths, that kind of thing. So, right, I just love this photo, so I wanted to show this as well. Millie standing out as the only woman at a conference on graphite intercalation in Japan. This is, I think it was 1970 for this one. And I will also just mention that in 1974, Millie was elected to the National Academy of Engineering for her contributions to the experimental studies of metals and semi-metals and to education. She was only the third woman to be elected after Lillian Gilbreth and Grace Hopper. Millie volunteered quite a bit as an NAE member, including as chair of the Committee on Evaluation Panels at what is now NIST, or National Institute of Standards and Technology. So back to her research. Millie never won a Nobel Prize, but her work was connected to several Nobel Prizes and potentially might be in the future as well. We never know. The first of these close connections was the discovery of Buckyballs, also known as C60 or Buckminster fullerenes. They're balls of carbon made of 60 atoms in a soccer ball configuration like you see on the right here. And then at left is a somewhat famous spectrum published by scientists at Exxon in 1984. In the early 1980s, Millie and others had been studying these mysterious carbon clusters that they were finding were coalescing when they were shooting carbon samples with lasers. So most everyone looking at this was looking for small clusters, just a handful of atoms big, but Millie's early results had suggested that clusters had to be much larger. So while she didn't do those subsequent experiments, she implored the Exxon researchers that they should look for larger cluster molecules, and they did that. And then they came up with this influential spectrum where you can see a spike at 60 atoms, which corresponds to C60 or Buckminster fullerene, and also a smaller spike at C70 corresponding to a slightly elongated fullerene. Looking at this just straight up, it's a little hard to tell exactly what's going on. And so for that reason and others, the discovery of Buckminster fullerenes wouldn't happen for a little while longer. So it'd be a number of years before scientists actually isolated and confirmed C60 as an icosahedron, or the soccer ball shape. And Millie's suggestion for all of this work really did lead directly to the discovery of the Buckyballs' eventual discovery and subsequent Nobel Prize. Buckyballs ended up having relatively few applications, but they did lead Millie down the path of predicting and then becoming expert in carbon fibers and in carbon nanotubes, which are essentially elongated buckyballs. And then I'm going to go to the next slide to show you what they look like a little bit. So as many of you probably know, carbon nanotubes have had many engineering applications, from sporting equipment to reinforced composites used for numerous structural applications, just everything from OLED displays, microchip memory, batteries for electronics, cancer therapy, fuel cell components, water purification, gas toxin sensors, all sorts of things. I could go on for a long time. But I'll note that one of Millie's key advances, along with her husband, Gene, and a couple of colleagues, was the early proposal that carbon nanotubes would behave very differently depending on the configuration of the carbon atoms. At the time, this was a wild idea when they first published it, but it came to be accepted and is now considered a foundational discovery about the properties of carbon nanotubes. In the last quarter of her career, Millie refocused on graphene, which is the single atom thick sheets of carbon atoms that she sort of first studied when she was looking at graphite. But the thing is, early in Millie's career, graphite was essentially just a model material. People didn't think that it could necessarily be isolated. And, you know, the idea was, we think maybe this kind of material could, you know, is what makes up graphite, and it's rolled up, it basically turns into carbon nanotubes. But it wasn't until the mid-2000s that graphene was confirmed to exist on its own and isolated by a team in the UK. So this discovery would help to confirm many of Millie's predictions earlier in her career and opened up a flood of new research into graphene applications, which of course continues today. Millie described often in talks that the number of graphene-related articles soared, and you can see that on the graph on the right here, which tracks scholarly citations related to buckyballs, carbon nanotubes, and graphene. Now, keeping in mind that Millie worked in this field since the very beginning, so you get a sense that, you know, all of these papers on this chart were in some way, you know, influenced, in most part anyway, by Millie, Gene, and her collaborators. And then, of course, in 2010, the Nobel Prize in Physics was awarded to two of the members of that UK team that isolated graphene. And both actually thanked Millie in their Nobel speeches, and she was invited to attend the ceremony as a guest of one of the winners, Andre Geim. Now, throughout her career, Millie took on numerous service roles at science and engineering organizations. And this section of her CV, honestly, that listed these activities is super long. And she had enormous influence as either a member or a chair of numerous committees and groups, some of which were at MIT, many of which were not. They were national, international, all over the place. As just one example, she served as in the presidential line of the American Association for the Advancement of Science, becoming its president in 1998. And in 2000, she was nominated by then President Bill Clinton in his last year of office to head the US Department of Energy's Office of Science. So on the left here, you can see Millie along with her husband, Gene, being sworn into that position. And you can actually see the future DOE secretary and fellow MIT professor, Ernie Moniz, sitting on the right. And at right is a photo of Millie touring Fermilab. After her visit, one grad student at the lab said, meeting with Dr. Dresselhaus was like doing group therapy. I should also note that Millie, in her work with APS, or the American Physical Society, and just frankly in general, she encouraged diversity work. But with the APS, she spearheaded an effort that continues today to review physics departments around the country to help ensure best practices in diversity, equity, and inclusion. So yeah, as I was saying, Millie was a strong supporter of underrepresented students and researchers. She did quite a lot to make engineering and science more diverse, and her influence was global. On the left is just a handful of some of her students that I mentioned in the book. I mean, she actually had something towards 60 graduate students and plenty of other postdocs and stuff. So it would be impossible to mention them all, but these are some of the people who, you know, I've gotten to know a little bit. Her first female graduate student, Debra Chung, now a professor at the University of Buffalo, is here. One of her earliest students, Shirley Ann Jackson, who of course had a prolific career in science and was the longtime president of Rensselaer Polytechnic Institute. Jing Kong, a close colleague in electrical engineering at MIT, and also Netia McCrae, a more recent MIT alumna who founded and directs a social venture encouraging young people to pursue STEM. Millie touched all these people, and she was considered like a den mother to anyone that she worked with, even peripherally. On the right is a family tree of Millie's academic colleagues made from author data of her 1,700 research papers. One of her former postdocs put this together and offered to let me put it in the book, which is pretty awesome. So he told me, his name is Mary Hoffman, that there are more than 4,800 branches representing colleagues around the world. And here's a beautiful picture of Millie. She never took home a Nobel Prize, as I said, but she was highly honored in many other ways. She earned about 40 honorary doctorates or degrees, they might not have all been doctorates, from other institutions around the world, and was recognized with countless awards for her research, her service to engineering and the world, and also, of course, her teaching and mentorship. Among those were the National Medal of Science, and she was the first woman to win that honor in the category of engineering. And in this picture, she's seen in 2012 accepting the prestigious Kavli Prize in Nanoscience from the King of Norway. She was the first person, man or woman, to win a Kavli Prize as a solo recipient, and she ended up donating her $1 million prize money to up-and-coming researchers. So I met Millie just one time. It was a wonderful experience. One of my side hobbies is creating custom Lego minifigures of actual scientists and engineers as a way of promoting them and putting them on social media and just kind of getting people to talk about science and engineering as something that everyday people do, and that they're changing the world, of course. And so when I got to MIT, I immediately knew that I had made one of Millie. I wanted to connect with her and just give it to her, frankly. So I emailed her one day, and within like an hour, she emailed me back saying, "Oh, I remember you. Like, there's a picture of your minifigure on my bulletin board and people love it." So that was slightly strange because, I was just kind of a little bit starstruck, and she invited me down to come bring the minifigure, and we talked about women in science generally and being from New York, and she was super warm, and obviously I'll never forget that day. And then when she passed away in 2017, a few months after that, I was asked by some colleagues at the MIT Press if I might be interested in writing a book about her life and career. And so, of course, I did not want to pass up that opportunity. So I did that. And when we came time to launch the book, I decided to update the minifigure and make some. And thankfully, the MIT Press was helping me with that. And we got to give them out as part of our launch. So that was great. So that's my story of Millie Dresselhaus. Honestly, I learned so much about her background and her life, way more than I could have possibly explained in this talk. So feel free to grab the book or get it from your library if you are interested in more. Thank you again for giving me this opportunity, and I can't wait to hear from the rest of you about all of your careers.
Great. Well, thank you so much for a wonderful talk. My road bike is a carbon fiber road bike, so now I know who to go thank for that.
Yeah.
I just we don't have a lot of time, but I do have one brief question. It would seem to me that Millie would have had lots of good reasons to be somewhat bitter, being a woman who had to break through all kinds of ceilings and everything. And I'm wondering if in your research about her life, you came across any thoughts about how she personally, as a human being, sort of overcame those, because it sounds like she wasn't really bitter about it.
About obstacles? Absolutely not. Yeah. Millie was the kind of person who, the more obstacles you put in her way, the more motivated she became. This could be seen from just all the way back to her childhood. One wonderful anecdote that I learned about when I was doing research for this book is, her family was very poor and they just didn't have a lot of money. So when she was growing up in New York City, she loved going around and just exploring as much as she could. And she loved the art museums and the science museums. In particular, she loved going to the Museum of Natural History in New York, and to the planetarium, the Hayden Planetarium. And unfortunately, she couldn't pay, but she managed to figure out a way to sneak in regularly. And so she would like sneak in and see the planetarium shows, and she would bring her friends and show them how she could sneak in. And one time she actually got caught sneaking in, and they just sent her packing. But she said, well, I had like a 2-week cooling off period, and then I just went right back to it, and they just never knew the difference. So that was just one example. She was very motivated to like learn the science and go out there and explore. Another example, of course, is later when she was a PhD student, her advisor had very traditional thoughts about women in STEM and didn't want to have anything to do with her, basically. And every time he saw her, he was like, "What are you doing here? Like, please get lost." And so obviously most people would get extremely discouraged by that. And certainly she was discouraged to a certain extent. She really, valued his judgment, but she wanted to do this. She wanted to accept a PhD and earn it. And so she went off and did her research all by herself. And actually, her PhD advisor didn't know what she was even working on until 2 weeks before she submitted her thesis. Nevertheless, she, got help from other people. She figured out ways to do everything herself, and she passed her thesis with flying colors. So it's just a couple of examples. She did not let things deter her. Yeah.
Exactly. Well, thanks again for a wonderful talk, and definitely everyone should go get your book.